So as we mentioned last time we were together, there's water that leaves your home that's considered wastewater. Would be the water that, while washing your hands, taking a shower, that type of thing. Also, any water that exits the home, so the water that comes out of your flushing of your toilets, that goes to a wastewater treatment or a sewage treatment plant. And what happens in that plant is the following. Now, I didn't uncover anything because it's very difficult for you guys to know what's going on in the treatment plant. Even with the pictures, it doesn't really guide you. But like water treatment, to make it potable or drinkable, the first thing is removing large particles or filtration. They call that primary treatment. And you have to know that the word primary treatment involves filtering, okay? You have to know that secondary treatment is a physical and biological treatment to get rid of organic compounds or organic waste or organic matter, right? And it also involves additional filtering. So with all that filtering, you're going to end up with solid remains eventually, and I'm going to talk about that in the next slide. But the third one is going to involve chemical treatment, which will break down inorganic waste. Now, I want you to know that in between all of these, there's heat, filtering, chemical reactions, right? All of that happens in a sewage plant. But no matter what the end result is, it's going to end up in an ocean or a large body of water. And that we call effluent. Remember, that was one of the questions on your past test and nobody knew what it meant? So it's going to be the liquid waste, or what we call the sewage discharge into a body of water that exits the plant. So whenever you see this in a picture, or you're told, no, it's a way back. When we did about, let's see, eventually I'll get there. That's effluent, okay? And it's obviously gonna have been treated, but it still has concerns. And if that effluent has levels of nitrogen and phosphorus, what could end up? Algae bloom, okay? So at the end of the day, you want to remember that no matter how much treatment, there's still going to be remains of organic compounds, organic matter, because this is water that's leaving your home that's packed with food, your skin cells, right? Hair, yes. Correct. Nitrogen and phosphorus leads to algae bloom. That process is called eutrophication, okay? And mainly it's a direct link to agricultural runoff, but any implement or any indirect form or direct form of nitrogen, phosphorus into a body of water can lead to that. All right. Also, during the treatment, all the solid remains is called sewage sludge. So during the filtering process, you're going to have a lot. It looks like mud or like soil almost. Very, very dirty soil. It can be used to fertilize, or it can be used to mix and build or mix and make concrete, which is actually great. Well, if you, obviously you wouldn't know this, but concrete was really, really expensive, and it was almost like in a shortage because of what it takes to make it was from obviously non-renewable resources. So this being used for that is actually a benefit. So treating water and taking the remains to make something we need is good. But at the end of the day, if we can eliminate sewage or wastewater in general, you'd be doing this whole process a good service. So we end with solutions, okay? And with every single unit from here on out, there's going to be acts you have to become familiar with. These have to do with water, and there's more, but these are the majority, or this is the main thing. Whenever you look at acts, you're going to think of the 70s. It wasn't until the 70s where people started to say, hey, we better do something. And the first thing they did was not improve your water that you drink. It was improve the water that you swim in, improve the water for fish. So it was taking quality or testing the water in lakes and rivers and making sure that there was specific standards to those bodies of water, and then reducing the amount of discharge or really any kind of waste being dumped from industry or sewage. That's the Clean Water Act. Water Pollution Control Act and Clean Water Act. Notice how they have the same dates? It's kind of acts get revised. You could think of them as the same thing. The same thing happens here. Wasn't until about the 70s and then kind of redone in the 80s where you have the U.S. Safe Drinking Water Act, or making your water drinkable. So this is linked to this, okay? Look how long it took, 2 more years. They knew the water was dirty and they knew we were filtering it, but let's really monitor the filtering process to make sure what you drink is safe. And all I want you to know for now is 70s. Dates are not the critical component here. Knowing that the U.S. Safe Water Drinking Act has to do with making water potable and making sure, and then these have to do with lakes and ponds and what chemicals are in it or what limitations to dumping. All right, so these next 2 slides, they're thinking slides, okay? These are the types of questions I could ask you on the test, which I'm going over now. I'm giving you a solution, and you have to give me the problem. So if I say, use organic fertilizers instead of inorganic, right? Or chemical fertilizers, let's say. Limit excess nitrogen and phosphorus, and use waterless toilets. What problem am I trying to solve? Eutrophication, good. We're trying to avoid, how do waterless toilets avoid eutrophication? Right? What I just said. You're going to end up in the sewage, and the sewage, even though it treats water, when it pours back into a lake or an ocean, it could have nitrogen and phosphorus in it and cause an algae bloom.
So a waterless toilet would be like one of those outhouses things?
A waterless toilet is what you covered yesterday without me. Which is this. Okay, waterless toilets either will have this built-in mechanism, and it uses like pressure and rotations to kind of collect, and then you have to literally dispense the products of the waterless toilet.
Where?
In somewhere. Fertilizer, compost, do something. Or you could have something like this, okay, which still will produce wastewater, but this will eliminate consumption, where you take the wastewater from your sink to power your toilet, right? You're still going to exit that water out, so it's less water coming into it, okay? I wouldn't say it's waterless, but at the end, it's going to save some problems with water.
Wait, does the toilet water go into the sink?
It can. If it did, and look, she asked a good question. Does the toilet water go back into the sink? At the end of the day, if that mechanism has a filtration system, it can easily go back. The same way your toilet goes into a sewage treatment plant and ends up back in your hands and in your body in a shower, it's the same process, right? Okay. Yeah, I know. I get it. All right. Reduce and restore wetlands and plant water absorbing crops. What are we helping? What solution? What problem is this a solution to? Yes, I would say definitely erosion, but more than that. Yes, kind of. Floods, guys. Remember that? Yeah, runoff. Remember that our water absorbing crops, our restoration of our wetlands is critical to help avoid future floods, especially in Florida. Controlled discharge from water plants. This should say from electric plants. Good job. If it was water plants, it would go back to eutrophication, right? So this is thermal. What would reduce erosion do? What's it going to decrease? It can. Runoff in general, okay? Which is going to be non-point pollution, right? Because we got to remember that runoff is natural. Our water should run off. But when it runs off with chemicals from soil that are packed with fertilizer and pesticides and other toxic chemicals, then it's going to end up in our body of water. Improve irrigation and toilets. What consumption? Good job. Or wasted water, or inefficient use of water, right? Or unsustainable use of water. Alternative energies, sources. So let's work backwards. Since I'm giving you, this is like Jeopardy. I give you the answer and you have to tell me the question. What is global warming? We want to prevent climate change, right? Because that leads to what? What water problems?
The increased temperature
Rising sea levels, which causes floods, and
and increased temperature.
More warming.
wait.
Less oxygen.
If there's more warming,
Lower oxygen. But it's like
that's true, but that doesn't affect water. We got that. What else?
algae degradation.
Droughts.
How does it cause drought?
So global warming or climate change leads to extreme weather. Write that down. Remember, we have extreme weather conditions because of climate change. Instead of having normal 4 seasons, we're having these weird, right, moments of rain, weird moments of droughts, freezing days, right? Super hot days. Okay. Require leak detectors in underground wells. What are we going to solve?
Miss Frank wants JJ. She said she sent you a text.
Okay. That's in the video. Leak detectors for underground wells will prevent what? Good. Aquifer or groundwater pollution. And why would we build dams? Prevent flooding and what else? Yeah, you know, dams will also help restore water. So that restoring the water cycle, because it helps with the whole process of the water cycle. So will help with overconsumption or lack of water.